Hi guys. I am Crystal, your friendly tutor. Today we are going to discuss all about practical transformer and its characteristics, operation, and standard ratings. First, we need to know a little background about transformers. What is a transformer, and why it is important? A transformer is an electrical apparatus designed to convert alternating current from one voltage to another. It can be designed to step up or step down voltages and works on the magnetic induction principle. Transformers reduce the voltage of electric current and make it safe for home circuits and electric devices. Without transformers, much of modern life would be impossible. You may wonder, how does electricity travel to our home? This is a simple diagram to show you the flow of electricity from power station to our homes. The power is being generated in the power station. Let's say that this power station generates 25 kilovolts. From the generating station's transformer is used to step up voltage. Then, power flows through the transmission lines where the transformers step up voltages for transmission from 25 kilovolts to 400 kilovolts. Transmission lines carries electricity over long distances. Then it goes through a neighborhood transformer to step down the voltage in order to be safe to use in electrical trains and heavy industry. The 400 kilovolts will be then 132 kilovolts and 25 kilovolts. The distribution lines where it carries electricity. Lastly, it goes through in a transformer on pole which steps down the voltage into safe ratings before entering our homes, hospitals, schools, workplace, and small industrial consumers. Characteristics of a practical transformer. The following are the main characteristics of a practical transformer. 1. It uses electromagnetic induction in transforming voltage levels. 2. The input and output power of a transformer has the same frequency. 3. This electrical machine is static, therefore there are no losses due to air resistance and friction unlike electric motors. 4. It has copper losses, since the windings are electrical wire with resistance no matter how small. 5. It has core losses due to eddy currents and hysteresis losses. Principles of operation of a transformer. A transformer obeys Faraday's law, which states that a voltage will be induced in a coil of conductor of proper orientation which experiences a changing magnetic field. Before exploring the operation of a transformer, it is useful to review the operation of a simple inductor, which is nothing more than a coil of wire usually wrapped around a ferromagnetic core material. If we apply an alternating AC voltage to this coil, it will generate an alternating magnetic field in the core. The magnetic flux developed in the core depends on how much voltage we apply to the coil. When an alternating current is allowed to flow through any of the windings, there will be an alternating flux produced surrounding the winding. The magnitude of this flux is proportional to the magnitude of the current flowing through the winding. The direction of the flux is according to the direction of current. The direction of the current in the winding can be found out by applying right-hand grip rule. This rule states that when we grip the right hand with stretching the thumb along the axis of coil or winding and other four figures along the direction of current in the coil, then the thumb indicates the direction of produced flux inside the coil along the axis. This is the basic diagram to show in order to understand how a transformer works. The fundamental relationship between voltage and magnetic flux for any conductive coil is given by Faraday's law of electromagnetic induction. V is equal to N times d phi over dt, where N represents number of turns and d phi over dt is the rate of change of the magnetic flux. The voltage ratio on a transformer can be calculated using this formula. V1 over V2 is equal to number of turns in the primary winding over the number of turns in the secondary winding, and this is all equal to A. The current ratio on a transformer can be calculated using this formula. Number of turns in the primary winding over the number of turns in the secondary winding is equal to the current of the secondary winding over the current of the primary winding, and this is equal to A. Standard ratings of a transformer. What is the rating of a transformer? Voltage rating. To protect the winding insulation from failing because of an excessive voltage applied. To have an idea about the magnetizing current and its magnetization curve of a transformer. Frequency rating. The most commonly used frequency ratings are 60 Hz and 50 Hz. In the Philippines, the standard frequency is 60 Hz for electricity grid. Apparent power rating of a transformer. The primary purpose of the apparent power of the transformer is to set the current flow through the transformer windings. The heating of the transformer coils depends on the current flow through it. The apparent power rating of the transformer has to account for the nature of the load since loads are not purely resistive. Review questions. Pause the video if you needed more time to answer the questions. The answers of the questions will be given at the end of the video. Thank you so much. I hope you have gained knowledge in this video. See you next time.